Hey, what's up guys? So in our last video we went over the basics of moments and torque, and we covered the basic definition just so as to give you an idea of what it is. Now in this video we're going to use that information to solve problems. So many times you will be given a worded problem which would require you to draw a diagram, and this will help you figure out what it is you need to do. So the problem says to determine the torque on a bolt if you are pulling with a force of 200 newtons directed perpendicular to a wrench of 20 centimeters. Now as you can see, I drew a diagram here. I'm not the best artist. However, this should give you a picture of what the question is asking you to do. So we have a wrench here, 20 centimeters, and it says that you are pulling upwards with a force of 200 newtons. So the wrench obviously pivots around the nut here, and the distance between the nut and the end of the wrench will be 20 centimeters. And we can also note that this force is also going perpendicular. So from that, we can say that the moment arm from the pivot point to the force is 20 centimeters. But remember, the SI units for moments is the Newton meter, so we will have to convert the centimeters to meters. So we know that 100 centimeters is equal to 1 meter, so 20 centimeters divided by 100 will give you 0.2 meters. Now we have our moment arm, 0.2 meters. So how do we find the moment? The moment now would be the force times the moment arm. So the moment about the nut will equal the moment arm, which is 0.2 meters, times the force, which is 200 newtons. So 0.2 times 200 is equal to 40 Newton meters. And that's pretty much it. Note that this force is going in an anti-clockwise direction, so the value will be positive. In this problem, things are a little bit more complicated. We have a lever measured 2 meters away from the pivot point, but note that the force here is actually at an angle and it's not perpendicular as we saw from our previous example. So we will actually go into how we actually solve this. So this force is actually going clockwise, and it makes a 45-degree angle with the lever. So now the first thing we need to do in order to solve this problem is to identify the moment arm. Now some might say that the moment arm is measured from the pivot point all the way to the end where the force is acting, but that is actually incorrect because it's not making a 90-degree angle with the force. Remember, the moment arm always make a 90-degree angle with the force which acts upon it. So what we need to do is actually to extend this line here. We can extend this line and make a 90-degree angle. It would be easier if I had a set square or something, but just know that it should make 90 degrees. Now the distance from the pivot point to the line, the extended line we made here, is the moment arm, which we will use in order to calculate the total moment of which is generated by this force. So how do we find this distance here? We'll call it x. Note that this actually makes a right angle triangle, so we can use Pythagoras theorem to actually solve this. So we have a 45-degree angle here, so we can say the sine of 45 45 degrees is equal to the opposite over the hypotenuse, right? So that would be, the opposite is x over the hypotenuse, which is 2. Therefore, x is equal to 2 times the sine of 45 degrees. Therefore, x is equal to 2 times sine, this stupid calc. Alright, 2 times sine 45. So x is actually equal to 1.41 meters. So from there, we can say that 1.41 meters, we can calculate the moment now. The moment about the nut, the lever, the pivot point at the lever, is equal to the force 150 times the moment arm, which is 1.41 meters. So that would be equal to 212, we'll just round it off, Newton meters. Why? Because the moment arm will always make a 90-degree angle with the force. So if it's at an angle, you extend the line and you draw a line from the pivot point until it makes 90 degrees, and you get that distance here. It will form a right angle triangle, so you can use Pythagoras theorem to solve for the distance between these 2 points. So that is it for this problem here. Also note that it's going clockwise, so this value here will be a negative value. In this problem, we're actually cranking up the complexity. This problem here actually incorporates the principles of moments. The problem says that a uniform rod AB of a weight 100 newtons and length 2 meters is supported by 2 vertical strings at its ends and carries a load of 20 kilograms as shown in the diagram below. Determine the tension in the strings. As you can see here, I drew the diagram here with the dimensions and the correct labeling. It's always important to draw your diagram so you know exactly what you're doing. So the principles of moments says that for a system to be in equilibrium, the net moments must be 0. In other words, the moments on one side must be equal to the moments on the other side for there to be no net moment, and therefore the system will be in equilibrium. Now, in order to start solving this problem, we must take moments from one side of the rod. So in this case here, we'll start taking moments from side A. Once the force is passing through a pivot point, the moment will be 0. So we'll eliminate T1 as a variable and we'll solve for T2. This must be done so that we can only have one variable in our equation. So by taking moments at point A, we're saying that we're making one end of the rod the pivot point, and by doing so at point A, we'll eliminate T1 as a variable. So taking moments at A, we have 100 Newton force here, which is the weight of the rod, and this acts through its center of gravity. Therefore, we can say 100 newtons times 1 meter, which is the distance from point A, plus 20 times 10, because remember this is the mass, and we must times that by gravity to give its weight in newtons. So 20 times 10, or 9.81 to be specific, that will give us 200 times its distance away from point A, which is times 0.5 meters. this will equal T2 times 2. So we're looking for T2. Remember we said in the principles of moments that the moments from both sides must be equal to each other. So this must be equal T2 times 2, which is the distance, the total distance away from point A. Let's simplify this and solve for T2. So 100 times 1 is 100, plus 200 times 0.5 is 100, is equal to T2 times 2. 100 plus 100 is equal to 200, equal T2 times 2. We want to get rid of the 2, so we divide both sides by 2. That cancels out, so 2 divided by 100 is 100, and that is equal to T2, and this is in newtons. So T2 is actually equal to 100 newtons. But I will need to show that in another video. This video has already been like over 10 minutes long, so basically all you need to do is take moments from B instead of A. You apply the same thing while taking moments at A, but instead you do it at B. I'm not sure what I'll be doing in my future videos, but I'll think of something. But anyways guys, thank you so much for watching. I hope you learned something, and I'll see you in the next one.